Alright, so today we're going to look at inequalities in one triangle. So here's our warm-up. In triangle RST, RU is an altitude, SV is a median. We need to find y if the measure of angle RUS is equal to 7y plus 27. So, first thing, RU is an altitude, which means that it goes from the vertex to the opposite side, perpendicular to that side. This is a 90-degree angle. SV is a median, which means that it goes from S at the vertex to V, which is a midpoint of the side RT. We want to find the measure of angle RUS. Well, find Y if that is the angle. RUS is marked there, just put an arc there. And if you notice, it is also our 90-degree angle formed by the altitude. So, that means that 7y plus 27 is equal to 90. So now, we just solve for y. We subtract 27 from both sides. (7y) is equal to 63. We divide by 7 on both sides. And y is equal to 9. So, no vocab for today's work. The definition of inequalities. So, for real numbers a and b, a is greater than b if and only if there's a positive number c such that a is equal to b plus c. So, for example, if 5 is equal to 2 plus 3, then 5 is greater than both 2 and 3. Properties of inequalities of real numbers. So these are our properties we've used a lot. The transitive property, for one anyway, and then also the additional property and subtraction property are basically what we just had there. But you can add some number to either side and it's still going to be greater than or less than, or you subtract some number from both sides, it's either still going to be greater than or less than, doesn't matter. The transitive property just says that if a is less than b, b is less than c, then a is also less than c. We'll use that here in a minute. And a comparison property, you can only have numbers less than, equal to, or greater than. They cannot be anything other than those three things. So the exterior angle inequality theorem says that the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So here's our triangle here. The side AC is extended past the vertex at C, forming angle 1. And angle 1 is the sum of angle A and angle B. We knew that already from the exterior angle theorem. The exterior angle inequality theorem, though, says that angle 1 is greater than both angle A and greater than angle B. Basically takes what we just had for the property, or the definition of inequality, and the exterior angle theorem, combines them together to form the exterior angle inequality theorem. So, our first problem here, we need to decide what angles are less than the measure of angle 14, based off of the things that we know. Vertical angles are congruent. The exterior angle inequality theorem. That's pretty much about it that we'll have to use here. So, angle 14, first I'm going to circle that in purple, just so we know where it is. It's over here to the right, on the top. It is an exterior angle to a couple of triangles. The triangle formed by angles 4, 5, and 11, which means that 4 and 11 are the remote interior angles to angle 14, and that means that 4 and 11 are two angles that are less than angle 14. Also, there's the triangle formed by angle 5, angle 2, and the combination of angle 3 and 4, which means that angle 3 and 4 together and angle 2 are remote interior angles to angle 14 as well. And since angle 3 and 4 combine together to be less than 14, 3 is definitely less than 14 by itself, and of course 2 is a remote interior, which means it is less than 14 by itself. Alright, so we also have 11 being a vertical angle with angle 9. So angle 9 is congruent to angle 11, which means 9 is also less than 14. Angle 9 is an exterior angle to the triangle formed by angles 6, 7, and 12. And because of that, 6 and 7 are the remote interior angles to angle 9, which means that 6 and 7 are also less than angle 14. And that is it. There are no other angles we can tell right away without doing any actual having the numbers of the actual measures of the angles that are less than the measure of angle 14. So now we're just going to list them out. Angle 2, angle 3, angle 4, angle 6, angle 7, angle 9, angle 11. 7 different angles, all less than angle 14. For this next question, it's the exact same picture, but now we want to list all the angles whose measures are greater than the measure of angle 5. So, again, we're going to circle angle 5 in purple. He's right here. Use the linear pair with angle 14 that we had before. So, we need ones that are greater than angle 5. So, angle 5 is a remote interior angle to several different angles. First off, angle 17, out on the outside to the left, is a exterior angle to angle 5 being a remote interior angle to it, which means angle 17 is greater than 5. Angle 10 has remote interior angles 4 and 5 in the same triangle, so that is also larger than angle 5. And angle 12, same exact, 4 and 5 are also the remote interior angles to it, which means that 12 is greater than 5. Now, from here we have two angles that are exterior angles to angle 10 and angle 12. Angle 16 is an exterior angle with remote interior angles of 2 and 10. Since 10 is less than 5, greater than 5, then 16 is also greater than 5. And on the other side, angle 12 there, angle 15 is an exterior angle to the triangle formed by 6, 7, and 12. And because of that, angle 12 is the remote interior angle to angle 15. Since 12 is greater than 5, 15 is also greater than 5. And that's the only 5 that we can get that are greater than angle 5. Angle 10, angle 12, angle 15, angle 16, and angle 17. So, angle-side relationships in triangles. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. The alternative to that, if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So using that, we have a triangle here. We know that we're listing the angles in order from smallest to largest, so we need to find the side that is the smallest, and that's AB. AB is opposite of angle C, so that means that angle C is our smallest angle. Then we keep going. What's the next smallest side? Side BC. BC is opposite of angle A. So angle A is our next smallest angle. And then our last one, the only one left, 15.7 is the largest side. It is opposite of angle B. So that means that angle B is our largest angle. So the order is angle C, angle A, angle B. Here we're going to go the other way. So we're going to set up the order of the lengths of the sides. So we are given angles. We're looking for the smallest angle. It's angle B. So the side opposite of it, AC, is our smallest side. Angle C is 55 degrees. It's our next smallest angle. Side opposite of it is AB. And the only side we have left, the angle we have left is A. 80 degrees is the largest angle, and the side opposite of it is BC. So our last problem before our exit ticket. Ebony is following directions for folding a handkerchief to make a bandana for her hair. After she folds the handkerchief in half, the directions tell her to tie the two smaller angles of the triangle under her hair. If she folds the handkerchief with the dimensions shown, which two ends should she tie? So we're looking for the two smaller angles. So, conveniently, we are given all three sides, and two of the sides are both 16. They're both smaller than our third side. So, here's our 16s. That means that the angles opposite of them are the smallest angles. So, angle Z and angle Y. So, angle Y and angle Z. And here is, we did a little quizzes that day. Here's your exit ticket.